We know that the force system can be of two types. That is a linear force system and concurrent force system. And in the previous video, we had discussed in detail about the linear force system. And in this video, we discuss in detail about the concurrent force system. We try to understand what the concurrent force system is, what are the peculiarities of the system of the force, what differentiate it from the linear force system, and finally the goal of every discussion, the resultant of the concurrent force system. We try to see what is the resultant of the concurrent force system in the most simplified manner. As I told you before, these are quite important topics from basic biomechanics that can be asked in your university examination or any competitive exam. So let us expand our concept and master the concurrent force system. As I told you earlier, a linear force system exists when two or more force acts, okay? Two or more forces act on, what are the important points? Same segment, right? In same plane and in same line or collinear. So these were the characteristics features of a linear force system. Now what is concurrent force system? Can you always assume in your human body that forces will pass exactly in the straight line like this? Can you just always imagine that when there is a force upward, there will be definitely a force downward? Is this the scenario always? Absolutely no. In human body, there are scenarios in which the forces acts, that means two or more forces acting on the body. For example, this is our reference point, will act on some angle to each other. Will act on some angle to each other. If there is an angle between two forces, then such forces are all known as what type of force? The concurrent force system. When there is an angle that exists between two forces acting on a same segment, that's important. Not two different segments, two or more forces acting, okay, not just one force. Definitely you need at least two forces. When two or more forces acting on a same segment lie at some angle to each other, then such forces are called as, or such forces become the part of concurrent force system. Such forces becomes the part of concurrent force system. What is the difference between linear and concurrent? The linear means it is in same plane, it is in same line. Those things are different in these forces. It may lie in different plane and it may lie in different line. But these two factors, the number of the forces are both two or more and they are acting on the same segment. So define with me, how can you define concurrent force system? When two or more forces act on a same segment or an object. We are taking our reference as a human body, so we take it as same segment. When two or more forces act on a same segment, lie at an angle to each other, then such forces becomes a part of the concurrent force system. Such forces are known as concurrent forces or concurrent force system. I hope that is clear. It is so simple than this one. Here you need to remember same plane and same line. But in this one, you just have to remember there is an angle between these two forces. There is an angle between these two forces. That's a key point over here. Don't forget that one. Right. Now, the simple discussion proceeds to finding out the resultant of a concurrent force system. The resultant of the concurrent force system can be found out by a technique known as a parallelogram, composition of parallelogram or parallelogram method of force composition. What is that? Parallelogram method of force composition or composition of a parallelogram. That is how we can define the concurrent force system. You might remember we studied about the dynamic stabilization of the shoulder, where we saw that static and dynamic stabilization. We saw that RIC is acting like this. We saw that there is, what is the other forces? There is the force of gravity acting like this, okay, and then we saw that the resultant is this one. That was because we considered that we take the advantage of resolving these forces as the parallelogram method or by the parallelogram method. Let us expand our concept to understand what is this parallelogram method of force composition. For example, let this be an object in human body, and let this be the first force that act in the object, okay, and let this be the second force that act on object. Let this be A and let this be B. Right now, okay. Now when you look at these two force vectors, you can see that they make an angle over here, right? They make an angle. Let us call it as angle theta or alpha or whatever it is, okay. So it makes an angle over here. Now my aim is that I need to find out where will the result act. Okay, for example, if this is the knee joint, if this is the knee joint of a person like this, okay, and here you have what you call the posterior capsule and associated structures, and here you have the anterior capsule and associated structures. Now both of them act as forces on to same object at the same place. Now where will the resultant, where will be the product, or where will be the net effect of that forces? You cannot simply tell it from here. For that you need to devise the parallelogram method. How do you do it? You draw a line which is parallel to the B force. You draw a line which is parallel to force B, same length and parallel. Now you draw another line parallel to the force A. Now you draw another line parallel to the force A. Now we see we got a parallelogram, right? It okay. Now you know that by mathematical formula, the diagonal of the parallelogram is the resultant of this force. The diagonal of the parallelogram is the resultant of this force. So the methods was simple. We have got two forces A and B with an angle alpha or theta between them. Now we try to devise the parallelogram method where we need parallel lines. So parallelogram means parallel line. So you draw a line parallel to B force B, where you get this one. Let me call it as a C, and you draw a line parallel to A. Let me call it as D. Now this becomes a parallelogram like this, and we know that the resultant of the parallelogram is its diagonal. Now we draw a diagonal intersecting these 2 points. This diagonal is intersecting these 2 points, and this type of forces has this resultant as the diagonal. And if you can find out the value of this diagonal, you get the net value of that force. You get the net value or the direction of that force. Right? If two forces are acting in this direction, okay, A and B, now you draw a parallelogram like this. I'm just drawing it fast, and this is a parallelogram like this, and now you get the resultant in which direction? You get the resultant in this direction, downwards, if these two forces are acting on an object like this. See, so we get the resultant. So we can get the resultant as well as the direction of the force. The resultant means the magnitude of the net force as well as the direction. So no need to confuse on anything. You just have to write down the resultant of a concurrent force system can be done or devised by the composition of parallelogram. There we have the two forces A and B, or any other forces you can mention. Take some example, and now we draw a line parallel to the force B, and we draw another dotted line parallel to point force A. Both of this line intersects at a point. From this common point of A and B, or point of application, this point is known as the point of application. From the point of application of A and B, we draw a line. we draw a line which is the diagonal of the parallelogram. It will intersect the dotted lines. It will intersect the dotted line, and that diagonal gives you the resultant, and that diagonal gives you the resultant as well as the direction of the resultant force. This is so simple. You just have to draw parallelogram method. For example, now you have minus 88 Newton, minus 80 Newton. You have to find out the resultant of this parallelogram, and you get the value for this one. You get the value for this one. But you should always remember that the resultant of these two forces has some characteristics, or the parallelogram method or the concurrent forces has some characteristics. What is that? The resultant of the forces will be acting from the point of application of that force. Earlier we saw that the resultant of the force will, if this is the two forces, the resultant will be acting at the resultant will be acting in between that forces, whereas in concurrent force system they will be acting from that point of application towards the top or towards the down. That is the difference between linear and concurrent force system. That is the difference between linear and concurrent force system. What is the unique difference? The point of application is the point of application of the point of application of the forces is the point of application of the resultant also, whereas in linear force system it may be between the two joints, or it may be more close to the heavy side, something like that. But here the point of application of the resultant will be also the point of application of two of the forces, that is each of the forces, they will coincide with each other. They will coincide with each other, right? Okay, now there is also another feature, that is if we extend these forces in concurrent force system, they will intersect each other. When you extend the forces in the concurrent force system, they intersect each other, whereas when you extend the forces in the linear force system, they overlap with each other. When you extend the points in the linear force system, they overlap with each other. When you extend the forces in the concurrent force system, they intersect each other. What is the point? That is intersect each other. So now you define the linear force system, concurrent, and what are the peculiarities of the concurrent force system, and now the differentiation between linear and concurrent force system. The point of application would be the point of application of the resultant too. When the forces are expanded or extended, they intersect each other. You can see from this diagram, they intersect each other, but here they overlap with each other. Now what will be the value of the resultant? What will be the value of the resultant? The value of the resultant will be less than sum of both these forces. For example, sum of A and B. That is, the value of the resultant will be always less than that of the sum of A and B. More correctly, minus 88 minus 80 Newton. It becomes a 168 Newton. So this value will be always less than that of the sum of both these forces. Okay, it will never be greater than. That is, there is a proportional relationship between resultant of the concurrent force system and the forces. What is that? There is a proportional relationship between the resultant of the concurrent force system and the individual forces. What is that proportional relationship? It will never be greater than the sum of A and B. It can be greater than A. For example, this is 128 Newton. If the resultant it is greater than A, it is greater than B also. But it can never be greater than the sum of A and B. It can never be greater than the sum of A and B. Now, by mathematical calculations, you know that by the rule of cosines or law of cosines, the parallelogram method, the resultant is the square of a square plus b square minus 2ab into cos beta. Okay, so this is angle is alpha, and this or theta, and then this angle, you can say that you get an angle over here which is beta, and this one will be the same angle because 180 minus beta. So if you take it in that way, you will get an answer to this equation. But no need to worry, you don't have to study this. That is because in human body, we don't get an angle of application of the force. So we don't have to apply this one. Unless we are trying in the clinical scenarios, in the research labs, we cannot find out the value of this angle of the forces. So once we can't find out the angle, we cannot use out this formula, and this becomes irrelevant. So what we need in human body is, we need to know the magnitude, which direction it is acting, or whether it is a larger or smaller force. Just that we need. So if you want down, you can write down this formula in concurrent force system, the resultant, or by the parallelogram method, or by the mathematical calculation is equal to root of a square plus 2b square minus 2ab into cos beta. If you want only, otherwise just forget that, because we don't have to depend upon this formula in human body. For example, in deltoid force calculation or static stabilization, did we use the formula? Absolutely no, because we just need the direction of the resultant. That's only important for us. Okay, but of course, if you are going for a research purpose, or if you are in some research labs, definitely you need to find out the value of the forces and in which angle the force is going to produce more force or resultant, or which angle it is more efficient, etc. Then you need to study this one, otherwise you don't have to. Okay, so take it or leave it. Okay, so now let me summarize the concurrent force system. What is concurrent force system? And two or more forces acting on a segment lies at an angle to each other, then that forces are the part of concurrent force system. The resultant of the concurrent force system can be found out by the composition of parallelogram method, where you have to draw two parallel lines and a diagonal which intersects the parallel line and the point of application. The diagonal gives you the resultant of the forces. The characteristic feature of the concurrent force system, two or more forces are there, they are acting on the same segment, definitely, then they both lie at an angle to each other. Then if you intersect, or if you expand the points, if you expand the forces, you get them intersected each other, they crisscross each other. And finally, we have another one more point in the concurrent force system, that is the resultant will be at the point of application rather than in between the forces, as like the linear force system. In concurrent force system, you have to finalize by telling that the magnitude of the resultant has a proportional relationship between, what is that? A proportional relationship between two individual forces. The resultant will always be less than the sum of individual forces, will never be the greater than the sum of individual forces. And by mathematical formula, you can find out the resultant if you know the value of angle between them by the equation a square plus b square minus 2ab into cos beta, or force A into force b square minus 2 into force A into force b into cos beta. Why do you need that? If you don't need, you can just skip on. But if you want to 3 out of 3 or 5 out of 5, just write down this equation and tell that in human body we don't use, or we don't find out angle unless in the clinical scenario. So this become irrelevant. We just need the diagonal of the system. So that is all about the two type of force system in human body, linear and concurrent force system. So be thorough with it. Just draw some diagrams, do this and practice this. With this, I wind up this video. See you with another video on basic biomechanics. And definitely, if you like the video, don't forget to click the like button. And if you haven't subscribed, consider subscribing to this channel.